Let's learn Business Statistics second unit. This unit is based on the measures of central tendency, which we know as averages. Averages are the mediums which are useful for sampling as well as for determining the population's representations and what that population and the sample is having a relationship that can be determined by the analysis of the averages taken. So first of all, we will understand what is the measure of central tendency. Measures of central tendency is that value which provides information about all the averages where, or we can say that all the average values of a data set. This is also known as mean, median, and mode. That means the basic categorization of measures of central tendency, which you can understood as mean, median, and mode. They are the most commonly used measures of central tendency. This is also known as the unique value around which all the data observations are surrounded, or we can say clustered. So this is a unique value for the representation of the data. This is the value, or we can say that this average is also influenced by all the observations we have taken. The information which we have recorded in the forms of the facts in the collection of the data process, that actually affects the value of the mean taken. So let's move on to the in-depth meaning of measures of central tendency. The next categorization of measures of central tendency is mean, or we can start with the characteristics of understanding the mean. So the average, which we call as mean, median, and mode, what are the characteristics of that average? The characteristics or the main advantages or the importance of, we can say, averages is it should be based on all the observations we have recorded. It must be easy and simple to understand. Its calculation is not so hard or complex. You can easily understand that. It should not be affected by extreme values. It should be rigid or in a definite manner. That means it must be easier to understand or to define an average. It should be capable of further information. That means we can do several treatments, or we can use different methods to get information from the value which we have find in the form of average. So it is able for mathematical treatments. It should be affected, it can be affected, but it must be least affected by the extreme values or the fluctuations of the sampling. So if there is any fluctuation in the sampling, so it should be least affected by the fluctuations. So these are the characteristics of central tendency. The next is, what are the types of averages? If I want to define you average, then as I said, that it is a unique value which represents the whole population. So it is categorized in the basic three categories, that is mean, median, and mode. Mean is further categorized under three categories, that is arithmetic mean, geometric mean, and harmonic mean. So let's understand all these one by one. Three measures of central tendency, which I said, what are they actually tells us? What is the reference they are giving us? So first, we will take mean and we will discuss about that. Mean is also called arithmetic average, or we can say arithmetic mean. So this is an arithmetic average and is used for both continuous as well as individual series. Next is median. Median is also used for both kind of data, that is grouped and ungrouped data. So it is a value which represents the half, or which represents the middle of the whole data observations. The next is mode. Mode is that value which you find in a continuous manner. That means if the data is of continuous manner and frequencies are given there, so you can identify mode as the value which is having the highest frequency. So this is the representation of mode. Let's understand first mean. What are the formulas used for mean? As I said, that mean is used for both grouped as well as ungrouped data. So for group data, we have different formula, and for ungrouped data, we have different formula. So for ungrouped data, mean can be calculated by the formula given in the slides. That is x bar equals to x1 plus x2, so on, xn, and divided by n. So what is the x bar here? X bar means average. This x bar represents average. This is called mean. And to calculate a mean in ungrouped data, first of all, we need to add all the observations given, and then we divide the sum of all observations by the total number of observations. The next is grouped data. For group data, the formula of mean is different. That is, some methods are there which are used for group data. So they are direct method, shortcut method, and different step deviations methods like that. So for group data, this basic formula for understanding a continuous form data is x bar equals to summation fx upon summation f, where n is summation f. N represents the total number of scores. That means the sum of all frequencies. F represents frequencies of the given observations. X are the number of observations given. So we need to multiply the frequencies with the mid value, and after the summation, we can get the mean. So let's take an example to understand the mean. As I said, mean is the average. Mean is also called average. So for calculating the mean, what we do, add up all of the values to find a total. Whatever the values are given to us, we just make a sum of those values. And after summation, we divide all those values by the total number of values. So the example we have taken here is 2 plus 2 plus 3 plus 5 plus 5 plus 7 plus 8. That means these are the data observations given. And we have add up all these values to find the sum, which we get 32. And after that, we will count the number of values given. So when we start counting these numbers, they are 7 in value. And for calculating the mean, we divide the summation, that is 32, by 7, and we get mean as 4.57. So this is the method we can find the mean, called arithmetic mean. Let's discuss next mean, which we call weighted mean. For calculating weighted mean, we always have some weights, or we can say credits given. And by the help of those credits, we try to find out the value of the mean. So this is also having a simple formula where weights are multiplied by the percentage or by the data observations given. And after that, the summation is divided by the weights of the observations. And we get the weighted mean. So let's take an example which is given in your slides. A student's weighted mean is written exam. That means a student has appeared in different exams, and we are having the scores of that student along with the weights given. So you can see a column where weights are given, and you can also see the another column where the result of the student is given on the basis of the weights given. What we have to do here is, first of all, we will multiply the weights with the result. And after multiplication of these values, we find the sum of these values and divide that sum with the summation of the weights given. As we have done in this example, where 61 multiplied by 0.7 plus 87 multiplied by 0.15 plus 92 multiplied by 0.15. After finding the summation, we get 69.55. And below in the denominator, we will get the value 1. So on solving it, we get the mean, that is weighted mean, as 69.55%. This is the weighted mean of the student. So this is the way we can understand this another important mean called weighted mean. Let's discuss the another mean. The next categorization of mean is harmonic mean and the geometric mean. What is the harmonic mean? And what is the geometric mean? So to understand geometric mean, you can understand it as whatever the values are given to us, we just multiply all those observations and take the nth root of those observations. Here you can see some formulas which we have written where cube root of x1, x2, and x3 is taken. What are these values? This x1, x2, and x3 are the data observations, and we have taken the cube root of these observations because they are 3 in numbers. So geometric mean is to find the nth root of the observations given. In the same manner, if we are having the number of observations as, if we are having the number of observations as 5, so we have to take the 5th root of the observations. So in that case, what we will do, we will multiply all the observations given. We will multiply all the observations given. So this is the example with the help of which we can understand what is geometric mean. Here you can see that we are having a formula above, and after that we are having 2 examples where we are having 2 numbers 4 and 9, and we have to find the geometric mean of these 2 numbers. So to find the geometric mean of these 2 numbers, first of all we will multiply. First of all we will multiply them. First of all we will multiply them, and after that we will take the square root of those values. And the square, why we take the square root of these numbers? Because these are 2 in numbers. So we need to take the square root. In the next example, you can see that we are having 3 numbers. So we need to take cube root of these numbers. And these 3 numbers are 1, 4, and the next one, all these numbers should be taken as a cube root, and we will find the value. The next is harmonic mean. What is harmonic mean? This harmonic mean is also another average which is used for a set of numbers, which is used to calculate the mean of set of numbers. And here the number of elements will be averaged and divided by the sum of the reciprocals. So this is another formula we used to calculate harmonic mean. Let's take an example to understand the calculation of harmonic mean so that we can have a better understanding of this formula and what we have to do to find the harmonic mean. Let's move on to the example and try to understand. This is the way we can calculate harmonic mean. To find the harmonic mean of 1, 2, 3, 4, 5, we have basically taken 5 numbers, and the first step we have to do is we just calculate the total number of values. That means how many values are given. So we are given with 5 values. The first value is 1, the second value is 2, third is 3, and the fourth is 4, and the fifth is 5. So after finding the number of values, next what we have to do, we have to take the reciprocals of these numbers, and we have to divide the sum by the reciprocals sum. So for harmonic mean, what we have to do, in numerator, we will take 5 as the number of observations are 5. So we will take 5 in the numerator, and in the denominator, we take the sum of the reciprocals of the numbers given. So in this case, you can see that we have taken the reciprocals as 5 divided by 1 by 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 plus 1 by 5, and so on dividing and summation and adding, we will get the harmonic mean as 2.19. So if you understand the formula, you can understand how to calculate or how to solve the problems. So this is the example which helps you to understand harmonic mean. Next, move on to the basic or the next important average, which we call median. What is median? Median is actually the average which is called the middle value of the data observations. And it follows a procedure to find out the median of the given observations. And that is, first of all, we need to arrange the data in ascending or descending order to find out the median. And after that, we check that if the number of observations given is odd, if the number of observations given is odd, then the formula is different. And if the number of observation is even, at that time the formula is also different. So for odd series, median is find out as n plus 1 by 2th term. And for even observations, median is calculated as n by 2th term plus n by 2 plus 1th term divided by 2. Next comes an example. Let's understand median with the help of an example. Find the median of the following set of numbers. We are given a set of numbers which we use to calculate median. And these numbers are 8, 14, 8, 45, 1, 31, 16, 40, 12, 30, 42, 30, 24. These are the values of which we need to find the median. So the first step we will take here is, first of all, we will arrange the data in ascending order. So you can see here that we have arranged the whole data in ascending order. And after that, we will find that value which is in the middle of the series. And how we will do that? We just count the values, how many values are these, and use the formula which we have learned in the previous slide. So this is the way we can find the median. Let's take an example of the given data set, which is having values in decimals. This is 46.4, 29.3, 48.2, and so on. Some values are given. And first step, as I said, to calculate the median is, you have to arrange the data in ascending order. So in the slides, you can see that we have arranged the data in ascending order. And after that, we will use the formula given. So here, this is the even series, as the numbers are 6, 7, 8. This is the data observation is having 8 values. So that means this is an even series. And for even series, the formula is n by 2th term plus n by 2th plus 1th term. So n by 2th term is 39.5. And the next term which we need to add is 41.3. So we will add 39.5 to 41.3, and on getting the summation, we divide that value by 2. So we will get the median. The next important average is mode. Mode is often said to be that value which repeats number of times in a data. So this is the most repeated value of the given data set. And if the frequency is given, if the data is of grouped data form, then the frequency given tells you that what is the mode of that given observations. So it is the value which repeats number of times or is having the greatest frequency in the data given. Let's understand mode in detailed form with the help of an example. And before understanding the example, let's understand the formulas used for mode. Mode is also used for calculating grouped and ungrouped data. So the formula used for ungrouped data, where there is no limits or there is no grouping of the data, there is no frequency given in the data, at that time, we simply calculate mode by the number of times a value repeats in the given data set. But for grouped data, the methods little bit changed. For grouped data, we need to calculate mode with the help of the different formulas given. So the formula given for mode is written here, and this is the formula which we use to calculate mode for the grouped data. This formula is usually used in the form of different data groups given and is specifically used for group data. So let's understand what is written in this formula. So this I represents the median class, that means class interval. The L represents the lower limit of the class chosen. This FM represents the frequency of the class chosen, frequency of model class we call, and this FM minus 1 represents the pre-model class frequency. This FM minus 1 and FM plus 1 represents the next frequency of model class. And just like pre-model class and post-model class, both frequencies are used for calculating mode value. And this I, as already told you, this is the class interval. So for ungrouped data, let's understand how to calculate mode. Find the mode of the following series. This is the question given here. You can understand it as 8, 9, 11, 15, 16, 12, 15, 3, 7, and 15. So here you can see which value is repeating highest number of times. You can answer it yourself that 15 is the value which is occurring maximum number of times. And thus the answer of this question is the mode of this series is 15. So this is the way we find the mode of ungrouped data. Let's understand how to find the mode of grouped data. For grouped data, first of all, we check the class which is given. And after making the class intervals, after using the class, after fixing the class intervals, we start calculating the mode with the help of the formula. So here the question is given, on the data given, you can see here the frequency is given and the class interval is given. So on the basis of this table, the highest frequency of the given data is 14. The highest frequency is 14. So the model class is 11 to 20. And therefore, we will just try to find out the mode, where mode is calculated on the basis of FM, FM minus 1, and del 1, del 2. This del 1, del 2 is actually the formula which we have used, which we have discussed previously. This is L, which is called 10.5, the lower limit, because this is the class interval which we need to convert. First of all, we need to make it equal class interval. So this will be 0.5 should be decreased from the left side and 0.5 should be added on the right side to make it a proper class interval. And that's why this is the way we will find the mode of this class. So first of all, we will convert the class interval, just like decrease less 0.5 from the left side and add 0.5 to the right side. Now, after understanding the mode, you can understand that these are the averages. These are the most important averages which we used for calculation or which we used for representing the whole population. So mean, median, and mode are the most important averages, which are also known as measures of central tendency. But in spite of these measures of central tendency, there are some also other statistical tools which we also learn in this unit, which are used for calculating, just like which are used for calculating the mean. For example, we just need to calculate range, we used to calculate quartiles, we used to calculate measures of dispersion. They all are related with the statistical measures. So measures of central tendency is the single aspect of the statistics. In this second unit, we have studied 3 basic measures of central tendency, 3 basic averages, which are used to study the whole data observations. But some other statistical tools or some other statistical measures are also used for calculating the clustered data, the meaning, to derive the meaning from the cluster, the collected data. And those measures will be studied in our further lectures, where we are going to study measures of dispersion, where you will study range, you will study quartiles, and you will also study one thing more, that is how to use all these to get information from the data given, how to implement these informations, how to apply these informations given, and how to make, just like I said, mathematical treatments. We do it's able to do mathematical treatments to the averages. So there are number of cases where you can study means in a different modes, in a different manner. So the series are different. We are having individual series, we are having group series, and we are having class intervals, which are exclusive as well as inclusive. So all that can be understood when we solve the number of problems. As you go through the number of problems, as you start solving the number of problems, you will understand the applications of mean, median, and mode. So this is all related to measures of central tendency, and the rest of the data, the rest of the part of this unit will be discussed in our next lecture. So